Welcome to All You Need to Know About Functions. This is not an extensive presentation, so I'm calling it part one, just in case there are sequels. So the first thing need to know is what the heck is a function? A definition that I have is that it is a set of ordered pairs where for each input there is exactly one output. These pairs share a relationship between each other. And a set is just a collection of those pairs that all belong together in one group. So moving on, I have some examples of some ordered pairs. You see those squiggly lines that are around the groups of pairs? Those just show what is in a single set. So in the first example, we have 4, 8 is a pair of numbers, 5, 10 is a pair of numbers, and 6, 12 is a pair of numbers, and they all belong in the same set. When you look at these examples, you'll notice that there are two numbers in the parentheses. Those are the pairs. The first one is represents the x-coordinate. You're familiar with graphs, so you know what coordinate points are. And so that is the x-coordinate, and it represents the input of the function. And the y-coordinate represents the output. Looking at the other examples, you can see that they can have decimals. You can see that they can be big numbers or small numbers. And then also the last point under examples, see how every single input is different, but the output can be the same. So 1512 and 712, the input, for every input, it has to be a unique number, but the output can be the same number. And that's going to be important to remember later on, because if you look over at the non-examples, if you see the same number in the x-coordinate position twice, that means that it is not a function. So if you see 525 and 513, that's not a function because the input is the same and they're matching to different separate outputs. All right, so moving on. How are functions represented? I just showed you that they could be represented as ordered pairs or coordinates, such as 0, 3, 4, 6, or 8, 9, but you can also turn it into an arrow diagram where there's like two ovals and you put all of the x coordinates or the first number in your ordered pair on the left side, and you put all of your outputs on the right side. And then you draw arrows to where your numbers on the left meet up with the ones on the right. We also have a table, which is similar to the arrow diagram, except that it just more in a chart where you can just read across and see how everything matches up. We also have a graph, so you can take those ordered pairs, those coordinates, and plot them on a graph to see what kind of graph that you have. We'll mostly be working with linear functions this year, but later you'll see that there are other kinds as well. It's also important to know that functions can be expressed in several ways. So I've already told you about input and output, and with the coordinates, I've told you that the left side is x and the right side is y. So the x is the input and the y is the output. But there's also a couple other terms. One is domain. So domain is another way to say input or x. And then the other is range. And something else you might see later is N and A. N stands for term, and A stands for a sequence number. So I just want you to be familiar with those so that if you see domain and range, you understand that it's similar to input output or XY or term and sequence number. So let's give it a little practice. I want you to look at these tables that I've created for you and determine whether or not they are functions. So if you need, you can pause the video and come up with answers in your head and then replay when you're ready. So the first example is the input is a person's age in years and the output is their height. And the answer for this one is no, because as you can see in the X column, 9 is shown 2 times, which means that 9 had 2 different outputs, because a 9-year-old could be 54 inches tall, but a 9-year-old could also be 61 inches tall. It just depends on who the 9-year-old is. And so if you have the same different heights for the same age, then it can't be a function. The next example is number 2, which is the input of the number of hours. The input is the number of hours a car is parked in a parking garage, and the output is how much it will cost per hour. And it's about $5 per hour. And the answer for this one is yes, it is a function, because each hour you're there, the cost of being in the parking garage increases. So if you're there for 1 hour, it's not going to cost you both $5 and $10. It will only cost you $10 if you are there for 2 hours. So each term has its own sequence number. And then the third example is the input is the number of days and output is the number of minutes it takes Curtis to walk to school each day. And I said, yes, this is a function, because if you're counting the number of days he's walking, it takes him 13 minutes to walk to school on the first day. But unless he's walking to school multiple times a day, then it's only going to have one output. And then you can see that on the 4th day, he also walks 13 minutes. But it's still a function because each day only has one output, even if that number is the same. I want you to look at this equation, and you'll see that it's a pretty simple one. So it means that the output is y and the input is x plus 1. So if you put a number in for x, for example, if you put 1 in for x, then it would just be 1 plus 1, which equals 2. So try that for these other examples. If you put these numbers in for x, what is the output? All right, hopefully you had enough time to look at some of these. This example is if you put 17 in for x, be 17 plus 1, and the output is 18. And here are the answers for all the other ones. See, all you had to do was add 1, and that was your output. All right. One more example, I tried giving you an arrow table thing. The question prompt reads, during 1 week in November, Mr. Tharp decides to keep track of how many students come to class with their Chromebook charged. These were the results. Monday was day 1, 23 of the Chromebooks were charged. Tuesday, which was day 2, 15 were charged.